Hello everyone, today I have something to share. All my designer friends at some point might have created this very creative, very visually appealing vector assets. Now, in order to do that, we are all guilty of putting in a lot of gradients, putting in a lot of path data into these vectors, and also in some cases to put in that texture effect. We have all clipped raster images inside our vectors. Now, what it essentially does is cause a lot of performance issues in our applications, and in some cases also lead to ANRs, which is app not responding cases. Now, in order to solve for this problem, I have created a very small utility tool which goes by the name of Slim SVG. I'll give you a very brief demo. I'll just delete this existing file over here. Now I'll upload all my exported unoptimized SVG files in here. Okay, all the files have been uploaded. Some are queued and some have started getting optimized. Okay, so in order to explain to you what is happening essentially under the hood is the algorithm basically works in the form of iterations. So it will iterate over the optimized files. So iteration 1 would reduce a certain extent of your SVG, and then iteration 2 would basically take in the file from iteration 1 and try to optimize that further. The iteration stop wherein the delta is less than 1%, so it will stop the iterations at that point. And it also gives a complexity report, as in like what are the number of paths that are involved in this SVG, how many gradients had been used, and if there are any embedded images inside those vectors. So it will also give you a before and after comparison and also a preview, so that you can, as a designer, you could take a trade-off call, as in how much optimization is okay and what is the visual hit that you are willing to take. And it also flags a certain complex SVGs. So for example, let's just show you. In this case, this has been flagged as a complex SVG, and these are the reasons over here, which is a long path data, heavy gradients, and also masked elements that have been detected. And the tool smartly suggests in those cases to convert them into WebP files, which are raster formats. Okay, so now for this one, there is also an embedded base 64 raster image that has been detected. So yeah, it does that too. Now, for the raster ones, like for the complex SVGs, you could just start converting them to WebPs. We'll just wait on everything to get optimized smoothly and then proceed ahead to download them all together. Okay, so the WebP is ready over here. The WebP, okay, so this also needs to convert to WebP as suggested. Okay, all the files I think now are ready to go, and now I just have to select all of this together and download. So what the download essentially would give me is a zip file with an folder of SVG and WebP. WebP is only wherever suggested, and SVG is for all of these files, and also a PDF optimization report, which would have a table wherein it would compare all the files and give you a overall picture of how much size you basically saved. Okay, so the zip file is ready. I'll just open it up. Here are all the SVGs, the WebPs wherever suggested, and also the optimization report. So here you can see that there has been total reduction of 40%, around 40%, which is huge. And in the table you could just see like file by file what has been the optimization, and also like the WebPs wherever suggested. So let me know, guys, like whether this tool might be helpful in for your use cases, like wherever you create complex SVGs for your applications, Android applications, iOS, whatever.